Hello everyone. Today we are going to start lecture 05 of class 8 mathematics chapter number 3, which is understanding quadrilaterals. In this lecture we are going to talk about properties of parallelogram. We have already studied we have 7 type of quadrilaterals, namely parallelogram, rhombus, trapezium, square, rectangle, isosceles trapezium and kite. And now we are going to talk about properties of a parallelogram. So what a parallelogram actually looks like? We already knew that a parallelogram is a figure like this where A, B, C, D is a parallelogram, right? In this parallelogram there are certain properties, but what was the definition of parallelogram? It simply states that the two sides, that is CD and AB, should be parallel to each other. Similarly, these two sides, that is AD and BC, should be parallel to each other, right? So a quadrilateral ABCD in which pair of opposite sides are parallel is called parallelogram. Now other than that, what are the properties? What does this two parallel lines, opposite sides are parallel, so what does these two opposite sides give parallelogram? That is, what does they provide in terms of properties? The first property of a parallelogram is, the first property for a parallelogram is the opposite sides are equal. The first property is opposite sides are equal. But so opposite sides are parallel. So opposite sides are parallel and equal both. Okay. The opposite sides are parallel. That was in the definition of parallelogram, but it also implies that opposite sides are equal. So in terms of this figure, I am writing this as AD is equals to BC and AB equals to DC, right? Now what is the second property which these parallel lines implied? See, since the lines are parallel, so angle A and D are the internal angle on the same side of transversal. AD is the transversal for this DC and AB, so angle A and angle D should be supplementary because they are the angles on the same side of transversal. Similarly, C and B, the sum of C and B should be 180. With the help of these two things, we can prove that opposite angles of a parallelogram are actually equal. With the help of this particular thing, this particular property, we can clearly see that A plus D is also 180 and D plus C is also 180 because obviously AD and BC are also parallel. With this property, we can prove that opposite angles are equal. So in a parallelogram, opposite sides are equal and parallel and opposite angles are also equal. So with reference to the figure ABCD, we can write angle A is equals to angle C. Similarly, angle B is equals to angle D. So these opposite angles are equal. Okay, what is the third property? Now the third property depends on the diagonals. Okay, so if AC is the first diagonal and BD is the second diagonal, then third property simply says that both the diagonals bisect each other. Now what does we mean by bisection? Bisect means dividing a line into two equal parts. So this line AC is dividing DB into two equal parts. So there is OD equals to OB, and similarly this DB is dividing this line AC into two equal parts. So OA is equals to OC. So the third property simply states that diagonals bisect each other, right? So in terms of figure AB, what we can write is, since they are bisecting each other, so AC is getting bisected at the point O, so that is OA is equals to OC, and since BD is also getting bisected at point O, so OB is equals to OD. Okay, now we have no information regarding the angle of bisection. Okay, I will tell you in rhombus that this angle of bisection in case of rhombus is 90 degree. That is, the diagonals are perpendicular bisectors. But in case of parallelogram, this angle is not necessarily 90. That is, it can be 90, it cannot be. So we do not have any information at what angle these two sides are bisecting. Okay, let me explain you what I am telling. Let these be diagonals, so these are bisecting, but we do not have any information about this angle. It is 90, 80, 70, it can be anything, right? but in case of rhombus it will be 90. So here we do not have any information, and these are the three important properties. Also the definition itself is a property that the opposite sides are parallel, right? So we can say the opposite sides are parallel and equal. Now this is when we have already established that ABCD is a parallelogram. Then we are talking about the properties. But if tomorrow you say, sir, ABCD is a quadrilateral, it is not a parallelogram, we do not know it is. Now you say that ABCD is a quadrilateral and I tell you that opposite sides are equal, then can we call ABCD a parallelogram? That is, you are asking that if converse of these properties are true, that is, if in a quadrilateral ABCD, in a random quadrilateral, opposite angles are equal, can we call it a parallelogram? The answer is absolutely yes, and we are talking about the converse of these properties. Okay, so if ABCD is a quadrilateral, then also we can call, if ABCD is a quadrilateral and if any of the property holds, then we can call it a parallelogram. Okay, so first time the converse of these properties are also true. So the first property is, it was opposite sides are equal. Okay, so we can call a quadrilateral is a parallelogram. A quadrilateral is a parallelogram if its opposite sides. A quadrilateral is a parallelogram if its opposite sides are equal, right? So if in a quadrilateral opposite sides are equal, you can call it a parallelogram, and if it is a parallelogram, then opposite sides are equal. Okay, so converse is true, right? Second property was regarding the angles, so we can write a quadrilateral is a parallelogram. You can call any random quadrilateral a parallelogram if its opposite angles are equal. If its opposite angles are equal, right? So you can call it a parallelogram if its opposite angles are equal. Again, we can call a quadrilateral a parallelogram if its diagonals bisect each other. So again, same property, a quadrilateral is a parallelogram if its diagonals bisect each other. If its diagonals bisect each other, right? So diagonals can bisect each other. Again, we have one more property here, that in a quadrilateral, not both the pairs, but if one pair becomes equal and parallel. Again, what I'm telling is, a quadrilateral, let me write it first. A quadrilateral is a parallelogram, if it has one pair of opposite sides, parallel and equal, right? So we can call a quadrilateral parallelogram if we have information regarding only one pair, but they should be both parallel and equal. Okay, so let me tell you, if both the pairs are parallel, then also a parallelogram. Both the pairs are equal, then also parallelogram. But if only one pair is both parallel and equal, then it is also a parallelogram, right? So if this is a quadrilateral ABCD, and we have information only about the one pair, that is AB is equals to CD. Okay, AB is equals to CD, and if AB is parallel to CD, okay, if this is the case, then ABCD is a parallelogram, right? So we can have information regarding one pair also, but it should be both parallel and equal. So this was all about properties of parallelogram, right? Now since opposite sides are equal, so you can easily calculate the perimeter as, perimeter as 2 into L plus B, because length and breadth would be equal. Length and breadth Because opposite sides are equal, so both the lengths and both the breadths, the sum of both the lengths and both the breadths is the perimeter, so you can have perimeter as 2 into L plus B, right? Similarly like a rectangle. So there is nothing more in the property section. Now let us move on to the questions and let us apply these properties and find out how they work out in the questions, right? Show that in a parallelogram, sum of any two adjacent angles is 180 degree. So we have to show that in a parallelogram, the sum of any two adjacent angles is 180 degree. Now what are adjacent angles? We have already known. The adjacent angles are the angles which have one point in common. That is, if these are two arms, AB and AD and DC, then it has a point D. Okay. Now, for example, suppose AD and DC are two arms, then it has an angle D. Now what are the angles adjacent to D? Right, A and C. How? Because when angle A is formed, then they both have one arm common. That is in AD and AB. AD and AB and AD and DC. AD, this arm is common. So these angles, that is D and A, are adjacent angles. Similarly, we have A and B as adjacent, B and C and D are adjacent angles. So we have four pairs of adjacent angles. So we have to show that any two adjacent angles is 180 degree. That is the sum of any two adjacent angles is 180 degree. That is, any two adjacent angles are supplementary. We have to show it. Again, it is very easy because it will directly follow from the property of parallel lines and a transversal. So let us show it. So let ABCD be a parallelogram. For this purpose, we need a parallelogram. So let ABCD is a parallelogram. Now we have four pairs of adjacent angles, AB, BC, CD and AD. Okay, so what we have to prove is that the sum of any two adjacent angles is 180 degrees. So firstly, let us specify a target. To prove or to show, what we need to show is that angle A plus angle B equals to 180 degree, right? Because they both are adjacent angles, comma. We also have to show that angle B plus angle C is equals to 180 because it can be any two adjacent angles. Okay. Similarly, angle C plus angle D should also be 180 degree. And at last, angle A plus angle D should also be 180 degree. So we have four pairs of adjacent angles, and for all the four pairs, the sum should be 180 degree. Right. Now it is very easy. We can proceed as ABCD is a parallelogram. So clearly in ABCD, comma, AB is parallel to CD. Okay, AB is parallel to CD and AD is parallel to BC, right? So we have, since AB is parallel to BC and AB is parallel to BC and transversal AD intersects them at A and D respectively, comma, we can clearly see AB is parallel to this CD and this transversal AD is intersecting AB at A and CD at D, right? I mean, we all know that for two parallel lines, angles on the same side of transversal, that is these angles, angle A and angle D, would be supplementary. Okay, so it implies that angle A plus angle D is equals to 180 degree. How? Now what is the reason behind this? Because angles on the same side of transversal, since sum of interior angles on the same side, sum of interior angles on the same side of the transversal is 180 degree, right? So this is the reason. Again, similarly, you can say that BC is also a transversal, so angle B plus angle C should also be 180 degree. Yes, we can write it. It is true, right? Similarly, Similarly, we can prove that angle B plus angle C is also 180 degree. Again, they are angles on the same side of transversal, right? Also we can have AD is parallel to BC and DC comma AB are transversals, right? You can clearly see that AD is parallel to BC and DC and AB both are transversal for these lines. So again, for these lines, D and C are supplementary, A and B are supplementary. So implies that angle D plus angle C is equals to 180 degree. Again, angles on the same side of transversal, and A and B are also supplementary. So angle A plus angle B is also 180 degree, right? So this was all about this question. What we did was we applied the properties of parallelogram. Which property? Again, opposite sides are parallel, right? Since opposite sides are parallel, so we can clearly prove that any two adjacent angles are 180. We have 4 pairs, and for all 4 pairs we had proved that their sum is 180 degree, right? So this was all about this question. Let us move on to the next question and see the application of properties further. In this question, it says that ABCD is a parallelogram and angle D is given to be 115 degree. So we have angle D as 115 degree. We need to find the measures of angle A and B, and it is very easy question since we already know that angle B is just opposite to angle D, and in a parallelogram opposite angles are equal, right? So we can write it that way. In a parallelogram, comma, opposite angles are equal. So angle D is equals to angle B, which simply implies that angle D is equals to angle B, which implies that angle B is equals to angle D, that is 115 degree, right? So we have already determined the value of angle B. It was very easy. Now we have to find the value of angle A. Clearly, in a parallelogram, adjacent angles are supplementary. We also know that we can write parallelogram as like this also, right? So in a parallelogram, adjacent angles are supplementary, right? So we already know that adjacent angles in a parallelogram are supplementary, which implies that angle A plus angle D, since they are adjacent angles, they should be supplementary, so they are 180 degree. But we already know that angle D is 115 degree. So we can transpose this 115 degree on the right hand side, and we would get 180 degree minus 115 degree, and we will get angle A is equals to 65 degree, right? So this was angle A and this was angle B. So you can clearly say that we just applied the properties of parallelogram and we find out the value of angles required, right? Let us move on to the next question, which says two adjacent angles of a parallelogram are as 2:3. Find the measures of all the angles, right? So we need to find the measures of all the angles. So we can start the solution by assuming that ABCD is a parallelogram. Okay, let me make a figure. The figure is not required in this question, but you can make it for your ease. Okay, so let us take this as A, B, C and D. Okay, so we can take, let ABCD be a parallelogram, right? So two adjacent angles are angle B. So let angle A is to angle B is equals to 2:3. We can clearly see that A and B are adjacent angles, so we can take any two adjacent angles. Let angle A is to B is equals to 2:3, right? So it is given. Okay, so if you do not want to write let, you can remove it. So you can write let ABCD a parallelogram, comma, such that angle A is to angle B is 2:3. So that is more practical. Now we need to find out these angles. We need to find out measures of all angles. Now we can clearly see that the ratio of A and B is 2:3. So we can let angle A is equal to 2x degree and angle B is equal to 3x degrees. Since their ratio is 2:3, again we can cancel out this common factors x and we can get 2:3. Also A and B are adjacent angles. Angle A and angle B are adjacent angles of a parallelogram, right, comma. So angle A and angle B should be supplementary, so their sum should be 180 degree, which simply implies that 2x degree plus 3x degree is equals to 180 degree, which implies that 5x degree equals to 180 degree. Dividing both sides by 5, x equals to 180 upon 5, which implies that x equals to 36 degrees, right? So we have got x equals to 36 degree. Now we have to find the measures of all the angles. So angle A is equals to, clearly opposite angles are equal in a parallelogram, so angle A is equals to angle C, but angle A was equals to 2x degree, which is nothing but 2 into 36 degree. So angle A and angle C both have the measure 72 degree. Similarly, angle B, which was nothing but 3x, is also equals to angle D because opposite angles are equal. So it is equals to 3x degree, right? So we can multiply 3 by this 36 degree and we can get 108 degrees, right? So these are the measures of all the angles. Angle A and C each measure 72 degree and angle B and D each measure 108 degree, right? Let us move on to the next question. I hope you got this question. This was very easy question, just on the properties of parallelogram. So this question says, in figure ABCD is a parallelogram. So this question says that in figure ABCD is a parallelogram in which angle DAB is equals to 75 degree. So angle DAB is equals to 75. It is clearly seen. And angle DBC, that is this angle where BD is a diagonal, this angle is 60 degree. We need to calculate angle CDB and angle ADB. CDB, that is we need to find this angle, and angle ADB, that is A, D and B, and we need to find this angle, right? So what we have to do, we have already assumed ABCD to be a parallelogram. Okay, let ABCD be a parallelogram in which these are the angles. So we have made the figure. So we can proceed further as in this figure we have already given ADB as 75, right? So angle C should also be 75. Okay, so how do we crack the question? It is very easy. Since opposite angles, we can start by, since opposite angles are equal in a parallelogram, comma, so angle DAB, which is equal to 75 degree, is equals to angle BCD, which is the opposite angle, which is equals to 75 degree. So we have got this angle as 75 degree, right? Now in triangle BCD we can apply the angle sum property and we can find out this angle clearly. So in triangle BDC, comma, angle BDC, which we have to find, plus angle DCB plus angle CBD is equals to 180 degree, which is nothing but the angle sum property for a triangle, right? So angle BDC, you can also write it as angle CDB, okay, plus angle DCB is what? 75 degree. We have just equated it to this angle, and angle CBD is already given to be 60 degree, and the sum total is 180 degree, which simply states that angle CDB is equals to 180 degree minus 60 degree, which is 120 degree, and 120 degree minus 75 degree, which is again, if you minus 120 from 75, you will get 45 degree, right? So we have angle CDB as equals to 45 degree. So this was the first answer, right? Now we have to calculate angle ADB. Since you have already calculated this to be 45 degree, okay, and ADB, what is ADB? ADB is nothing but, okay, let us first write AD is parallel to BC and DB is a transversal. Okay, now it is easier to explain. You can clearly see AD is BC. AD is parallel to BC because it is a parallelogram, so opposite sides are parallel, and DB is working as a transversal. So you can clearly see that angle this CBD and angle ADB are alternate interior angles, right? So angle ADB is equals to, so we can clearly see that angle ADB is equals to angle CBD. Angle ADB is equals to angle CBD, which is equals to 60 degree. How? Alternate interior angles, right? Since they are alternate interior angles and we know that alternate interior angles are equal, so angle CDB or angle ADB, not CDB, angle ADB is equals to 60 degree. So this is how you can calculate the angles using properties of parallelogram. Now let us move on to the last question, which simply states that the ratio of two sides of a parallelogram is 3:5. So the ratio is 3:5. Find the perimeter, find the sides of the parallelogram if its perimeter is 48 meter. You can clearly assume the parallelogram to be ABCD. Let us take ABCD to be a parallelogram just to indicate the figure. Okay, so ABCD is a parallelogram, right? Let ABCD be a parallelogram. Okay, so the ratio of sides is 3:5. Parallelogram such that ratio of sides, let us take any two sides, adjacent sides. Okay, so the ratio of two sides mean adjacent sides because opposite sides are equal, so their ratio should be 1:1. So this 3:5 is used for adjacent sides, such that AD is to AB, that is the length of AB is to AB is 3:5. Okay, so now we have represented the question that AD is to AB is 3:5. So since they are in ratio, let AD equals to X meter and AD equals to X meter, or you can take it for ease, AD equals to 3x meter. Okay, let the common factor be X, so let AD equals to 3x meter and AB is equals to 5x meter, right? In this we can cancel out this common factor and the ratio remains 3:5. Then what we are given, then according to the question, perimeter, we are given perimeter to solve the question. Perimeter equals to 48 meter, right? Which implies that what is the perimeter? AB plus BC plus CD plus AD is equals to 48 meter, right? Now what is AB? AB we have assumed to be 5x, right? What is BC? BC is equals to AD, which is assumed to be 3x. What is CD? CD is equals to AB, which is 5x. And what is AD? AD is again 3x. So this is equals to 48, right? Adding them we get 5 plus 3, 8 plus 8, that is 16x equals to 48 meter. Dividing both sides by 16, we will get x equals to 3 meter. So this is the common factor. Now what are the measure of the sides? You can clearly see that the sides of parallelogram are, so sides of parallelogram are 3 into x, that is 3 into 3 is equals to 9 meter, and 5x, that is 5 into 3 is equals to 15 meter, right? So they are the sides of parallelogram, 9 meter and 15 meter, and you can clearly verify that 9 plus 15 is equals to 24 and its double is 48, that is the perimeter is 48 maintained. So our answer is actually correct. Okay, so this was all about properties of parallelogram, and I hope that these questions were able to get you understand the fact that properties of parallelogram are very easy. There are only 3 properties: opposite sides are equal parallel, opposite angles are equal, and diagonals bisect each other. So this was all about this lecture. I hope you understand my point. I will see you in the next lecture. Till then, goodbye.